Our next step in the process for solving, working with linear equations is taking a look at what happens if my equation looks different than I'm used to. My typical linear equation is y equals slope times x plus y-intercept. The slope is always the number beside the x. The y-intercept is always the number that's by itself. The reason this is so nice for us is because we can graph the solution so easy. In order to figure out what ordered pairs make this true, it's so easy to graph them and figure it out. The y-intercept tells you where to start. So if it was a 4, I would go on the y-axis up to 4. 1, 2, 3, 4, put a point. The slope tells me how to move. If it was 1 over 2, I would go up 1, right 2, up 1, right 2, up 1, right 2. Each dot is a solution, an ordered pair that makes this true. If I take it and put it in my equation, it works. I could reverse it, down 1, left 2, down 1, left 2. There's so many dots or so many points that count as solutions, it's infinite. So we draw a line to show the infinite amount. That's what linear equations do for us. What ordered pairs make this true? Oh, this one, and this one, this one, this one, this one, this one, this one. Infinite amount. The issue is this. You will get equations that do not look the same. We want it to say y equals slope times x plus y-intercept. But you'll get equations that don't have y by itself. This is why solving becomes so important. Can we use algebra and move things to get y all by itself? 3 times x minus 2y equals 8. The thing I want to get by itself is the y. So what I'm going to do is get rid of everything else on this side. I have to get rid of a 3x, I have to get rid of a multiplied 2. So let's use our algebra. First of all, in any equation, I always want to take subtraction, turn to addition. Here is subtraction, turn to addition. This becomes a negative 2. Now I have to ask myself, can I get rid of the added number first? Yes, I can. What do I add to get rid of a 3x? I need its opposite. Its opposite is negative 3x. If I do it to one side in algebra, I must do it to the other. So let's see what the fallout is. Negative 3x plus 3x is 0. The only thing I'm left with on this side is negative 2 times y. On the right-hand side, how much is 8 plus negative 3x? Hopefully you say I can't add these because this does not have an x, and this does. They both have to have the same variable or none at all. So I rewrite it as 8 plus negative 3x. I did my add opposites. Next is multiply by reciprocals. How do I get rid of a multiplied negative 2? I need the reciprocal. What is the reciprocal of negative 2? No, it's not 2. No, it's not 1 over 2. It's negative 1 over 2. Now here's the different part. If I multiply, technically what we've been doing all year is multiplying the whole side by it. Well, this is easy over here because the only thing this works with is this. So it cancels out. And I'm left with y by itself. The difference over here is it's not just one term. So it's not just this times this. It's this times this and this. How do I show that I want to multiply this to both of these? Something has to go in my picture to get this to multiply to all of it. The fix is you must put parentheses in. Because I am multiplying the entire left side by negative 1/2, the entire right side by negative 1/2. How do I take a multiplied number and get rid of parentheses? No, it's not with your eraser. It's distributive property. So negative 1/2 times this, negative 1/2 times this. All right, so I'm going to start front ways. Negative 1/2 times 8 is negative 4 plus negative 1/2 times negative 3x. Negative 3 times negative 1/2 should be positive 3 over 2. And And I have an x at the start, so I should have an x at the end. Check. Am I where I want to be? Do I have y equals slope times x plus y-intercept? I'm close. This is not the slope. Why not? That's right, it doesn't have the x with it. Okay? I'm allowed to flip them. If 3 plus 2 was 5, so would 2 plus 3. All you have to do is rewrite it. Y equals, this is my slope, 3 over 2x plus, what's my intercept? Negative 4. So what you're going to do is take equations that don't look right, and I'm going to solve them to make them look like a linear equation. Basically, my steps would be this. 1 is try to add opposites, and it's probably going to be of the x. 2, multiply by reciprocals. Step 3, you're going to need distributive property. If you want to step 4 would be to switch the order. Solving for y, getting y all by itself.